You're welcome to the Rhemabotics math class. And we have bearing part 3. In our previous videos we've done introduction, which is part 1. Part 2 we did bearing principles. So in part 3 we are doing examples, solution to bearing problems. So we have a problem before us. And this is the first problem we are solving in this topic. So let's look at the problem. A student walks 50 meters on a bearing 0 to 5 degrees, and then 200 meters due east. How far is she from her starting point? Okay, let's go straight up to the illustration, because in bearing we're doing a lot of illustrations. The question has to be interpreted in the form of a diagram before we start solving it. So straight up, what is 0 to 5? What is 0 to 5? That's 25 degrees north, east, south, and west. Okay, so the distance is from point A, because the first point, point A, the second point, point B, so the distance is 50 meters. So this is our second point. I call it point B, north, south, west, and east. Okay? So let's look at the second part of the statement, which is then 200 due east. What does that mean? 200 meters due east is exactly 90 degrees. Exactly 90 degrees. So this is what? Point what? C. We still have our north. We still have our east. This point C. We have our south. Okay. Don't forget, the journey is from here and in this direction, and this is the final point. Now they're asking us to find the distance. That's how far is she from our starting point. So this is starting point, this is our final point. So the distance from A to C. So I'm going to join these 2 points. Perfect. So we need to find line AC. Line AC will tell us the distance, from our starting point to our final point. So how do we do that? So there is a value of probability, which is when you move due east, you move 200 what? Meters. Okay? You move 200 meters due east. So the question is, what is the angle here? What is the angle here? We need those 2 angles to get the angle between these 2 sides. And that will tell us, that will give us an idea whether we should use sine rule or cosine rule. In the previous video, I showed you some principles. And in that video, I told you we are going to use sine rule in some problems and cosine rule in some other problems. But what we determine whether we use sine rule or cosine rule, it depends on how the angle is placed. So, this particular angle is 25 degrees. Why is it 25 degrees? This line is parallel to this line. So this angle is equal to this angle because they are alternate angles. Okay? So this angle is equal to this angle because they are alternate angles. So what is this angle now? Since this is due east, this angle is what? 90 degrees. So 90 plus 25 is 115 degrees. 115 degrees. That's 150 degrees. So you can see we have an angle between 2 known sides and we have an unknown side. Now this tells us that we are going to use a principle called cosine rule. So use cosine rule. So if you have not watched that video on principles, go and watch it. And that principle, we said a squared is equal to b squared plus c squared minus 2bc plus l. So let's assume this side is our L, which is AC squared. Then here will be our B. Okay? Now, because of the labeling, we can work with B squared. Yes. We can say B squared equal to A squared plus C squared minus 2AC cos B because of our labeling. That means AC becomes small letter b. So b squared, which is AC squared will be equal to what is A? That's the side directly opposite capital letter A. That will give us, that's 200 squared plus C squared. The side opposite C, capital letter C, the small letter C, which is 50 squared, minus 2 bracket 200 times 50 plus B. What's the angle? 115 degrees. 115 degrees. Okay, so 200 squared will give us what? That's 4, then 4 zeros. That's about 40,000. Yes, 40,000. Then plus 50 squared will give us 25, then add 2 zeros, 2,500. Minus this time this will give us 2 times 200 times 50 will give us 10, then 3 zeros, that's 10,000. Then cos 115. So we have 42500 minus, that's 20,000 plus what? 1115 degrees. So we're going to use 20,000 to multiply cos 115. And what's cos 115? Cos 115 is minus 0.4226. So we multiply it by minus 20,000, and that will give us. Okay, so we have 42500 minus 20,000 times minus 0.4226. So minus and minus will give us what? Plus. So 20,000 times 0.4226 will give us 8452. So we're going to add it to the 42,500. Okay, so that will give us 50952. So that's not the answer, because that's just AC squared. So now let's get only AC. Only AC will be the square root of this value we have here. So what is the square root of this value? The square root of this is 225.7. So I'm going to add meters to it, because that's the unit of the other dimensions. So finally, we have answered the question, which is how far is she from our starting point. So this is the distance. You can see where she is right now. So, and look at where she started from. So the distance from our initial point to our final point is what? 225.7 meters. So thank you so much for being part of this particular episode. See you next time as we solve another bearing problem. Thank you.